Imagine your company uses 5 or 6 different software tools, CRMs, booking systems, payment gateways, support platforms, etc. And now you want your AI agent to work with all of them. So what do? You start by writing custom integrations one by one. Different APIs, different auth systems, different interfaces, and different SDKs. Very quickly, it becomes a mess. Managing all those integrations take a huge amount of time, maintenance, and engineering effort. But what if there was a standard way for AI agents to connect with external tools and systems? That's exactly where MCP servers come in. Hello everyone, welcome back to Building SaaS channel. In this video, we will understand what MCP servers are, how they work, why are they becoming an important part of AI ecosystem. And then we'll build our own MCP server using Python from scratch. Finally, we'll connect it with Claude and see the entire flow working live. Once again, welcome back to the channel. Let's get started. Let's start by understanding what MCP is. MCP is Model Context Protocol, an open source standard for connecting AI applications to external systems. Using MCP, AI applications like Claude or ChatGPT can connect to data sources, tools, and workflows, enabling them to access key information and perform tasks. Think of MCP like a USB-C port for API applications. Why does MCP matter? For developers, MCP reduces development time and complexity when building and integrating with AI applications. Now let's look at the architecture. When discussing MCP, we run into three main participants: MCP Host, MCP Client, and MCP Server. Let's look at each one of them. MCP Host, the AI application that coordinates and manages one or multiple MCP clients. MCP Clients, a component that maintains the connection to MCP Server and obtains context from MCP Server for MCP Host to use. MCP Server, a program that provides context to MCP Client. Now let's look at layers. MCP has two main layers, data layer and transport layer. The data layer implements a JSON RPC 2.0 based exchange protocol that defines message structure and semantics. Transport layer manages communication channels and authentication between client and server. MCP support two types of transport: standard input-output transport and streamable HTTP transport. Most important concept of MCP are primitives. These primitives specify type of contextual information that can be shared with AI applications and range of actions that can be performed. There are three core primitives that a server can expose: tools, resources, prompts. Tools are executable functions that an AI application can invoke. Resources are data sources that provide contextual information. Prompts are reusable templates that help structured interaction with language models. Now let's look at the implementation. So for this tutorial purpose, we'll be converting our car servicing application into an MCP server. We'll be using Claude Desktop to test our MCP server. You can download it from the link in the description. MCP is just a standard, and that standard can be implemented in any programming language. We'll be using Python and FastMCP. FastMCP is a standard framework for building MCP applications in Python. Let's start by initializing a new project using UVinit. Once the project is initialized, let's add FastMCP as dependency. Once the dependency is added, let's open our main.py. We start by importing FastMCP, a Python framework that lets you build MCP servers super quickly. Here we create our MCP server instance. We give it a name, B&W Car Servicing MCP Server. This is how it identifies itself to AI. The instruction parameters tells the AI what this server is for. In our case, getting customer vehicle profiles and booking service appointments. This is like a server's job description. As we have discussed earlier, there are three things an MCP server must expose: tools, resources, and prompts. Let's start by creating our very first tool. We are using MCP tool decorator to expose a Python function as a tool that AI can call. The first argument is a tool name. We give it book service. The description is critical. The AI reads this description to understand when and why to use this tool, so write it clearly. The function itself takes a date string as an input and returns a confirmation message. In a real app, this is where you would connect to a database or a booking API. For now, it simply returns a statement to show the concept. Our second tool, send booking email. Notice this one takes no parameters. The AI knows to call this after a booking is confirmed, purely based on the description. In the production, we would trigger an actual email. This is a great example of chaining tools. Our AI can call book service first, then automatically follow up with send booking email. AI orchestrates the workflow on its own. Next, we create a resource. And it's different from a tool. Tools are actions the AI takes. Resources are data the client can read and pass it in context when needed. We register it with a URI data calendar. When the client app needs to provide available time slots to AI, it fetches this resource from the MCP server and passes that data into AI context. So the model can read it and make informed decisions. This function returns a JSON string of available times. In real world, this would query your live calendar or booking database. Next, we create prompts. The MCP prompt decorator lets you define reusable prompt templates. This one takes a card type and date and builds a natural language instruction for AI. So instead of every client app writing its own prompt from scratch, they can just call this template. It keeps things consistent and clean across the entire platform. Then we do mcp.run, which starts our MCP server. By default, it runs over standard input-output transport, which is how tools like Claude Desktop communicate with. You can also configure it for HTTP if you are building something more production ready. And that's the whole server under 30 lines of Python. You have got two callable tools, a data resource, and a prompt template. So we have written our MCP server. But how do you actually connect it to AI? FastMCP makes it ridiculously easy with just one CLI command. FastMCP install Claude-desktop main.py. That's it. One line. FastMCP handles everything under the hood. It registers your server, sets up the config, and wires it to your Claude Desktop automatically. Once it runs successfully, you will see a confirmation message in your terminal right here. Now, if you're someone who prefers to do things manually, no problem. You can skip the CLI entirely and directly edit Claude's config file, adding the server parameters yourself. Both approaches get you to the same place. Now, let's jump into Claude Desktop. I'll open up Settings and head to Developer tab. And there it is. Our BMW car servicing MCP server is installed and running. Now, if I click on plus icon and navigate to Connectors tab, you will see our MCP server listed and active. And look at this. Below the server, you can actually see all the prompts and resources we defined in our code. Everything we have built is showing up right here, ready to use. Now let's test this end to end. I will use the prompt template we created. It is asking me two things, the card type and the date of servicing. I'll fill those in and hit submit. The prompt is now loaded directly into the conversation context. Next, let's pull in our calendar resource. Remember, this is a list of available time slots we defined with MCP resource. The client fetches it from our MCP server and injects the entire calendar into context window. Claude can now see all the available slots. Now I'm just going to type book me a service. Claude reads the calendar data from the context and asks me to pick an available time. It's working directly from the data we gave. I'll go with 10 AM. And now Claude automatically chains both our tool calls. First, it will call book service with the time we selected. The slot is confirmed. Then, without us asking, it follows up and calls the send booking email, because that's what description told it to do after successfully booking. Two tools, zero manual triggers, the AI handled the entire workflow on its own. That's right there is the power of MCP. You write the logic once in Python and any MCP compatible AI can discover it, understand it, and use it intelligently. No custom integrations or hard-coded prompts. And that's it for this video. We have understood what MCP is, We understood the layers of MCP and we understood the 3 core primitives. Then we have created a simple MCP server using FastMCP in Python. And we have connected with Claude agent and saw everything working end to end. If you have found this video helpful, like the video. And if you don't want to miss the upcoming episodes on building agentic systems, subscribe to the channel. Thanks for watching. I'll see you in the next one.